Hello, hello. This is Postgres FM, episode number 96. My name is Nikolay, founder of Postgres AI, and as usual, my co-host is Michael from PGMaster. Hi, Michael.
Hello, Nikolay.
So PGMaster, as I mentioned last time, is focusing on explain plans and helping optimize Postgres queries. And the topic I chose this time is very, very close to that topic, right? I mean, it's subtopic. I know many people discuss a lot of very in-depth materials around this topic, but let's just focus on basics just for awareness. And this topic is how plan caching works and generic versus custom plans. Because at very high level, we don't know about them at all, right? We know that explain shows us a plan. We know there is plan caching. We know PGBouncer since recently started supporting prepare statements, so you can avoid planning time because sometimes it's very costly. For example, if you have a lot of partitions, a lot of indexes, log manager contention can happen. So it's good, especially for queries which have very high frequency, for example, 1,000 times per second. It's good to just perform planning once per session and then rely on cached plan. But it's not really once per session, right? There are more nuances in this area. So let's uncover them and discuss.
Yeah, nice. At a kind of high level, I see people that are using ORMs and frameworks using prepared statements, sometimes without realizing it, or sometimes they know, but they don't really know what it means. Do you see a lot of people, is that the same in your experience? A lot of people using this without realizing, or are you seeing quite a lot of conscious choice, conscious use of prepared statements, even for people that aren't using it via an ORM or similar?
Well, my point of view on this world. On one hand, I think people are quite smart in general, but they are smart only when they are very motivated. And we know a lot of engineers don't distinguish binary tree and B tree at all, because they are not motivated enough to understand differences. Similar here, a lot of people, in my opinion, don't understand that one normalized query in PGSA statements might have different plans depending on parameters. This simple truth is something that should be understood, but it can be understood only when you are motivated, when you have some incident, for example, and you start off thinking, okay, this query can behave differently depending on parameters. So this is like basic knowledge. And honestly, I didn't realize it for quite long in my career as well. I thought, okay, this is so, but why is it important? Well, it's very important because looking at PGSA statements and understanding heavy queries, it's not easy to jump to optimizing these queries, especially when we talk about mixed situation, when it's also quite high frequency query, and also it has issues with not perfect indexes chosen, not perfect plan, not only just index only scan, that's it. So it means that we need to understand, okay, we depend on parameters, but which parameters should we choose for optimization?
When you say for optimization, do you mean we get to pgstat statements and it has these parameterized queries? Which ones do we put in order to run, explain, analyze buffers?
Right. This is unfortunately big gap between macro and micro levels of query analysis, which still exists. Of course, with addition of query ID to logs and to PGStat activity, we have this bridge between PGStat statements and individual queries which we can find in logs or PGStat activity. But still, I remember one lesson I learned in practice when I spent 1 hour or so optimizing some query. It was some parameter which was true or false, basically. And I was trying to optimize for value which was present in 90% of rows, majority of rows.
Yeah.
And it was, of course, difficult because selectivity is low, cardinality is high, right? But then I understood all this hour spent was wasted because it's never so. Never ever application runs this value, uses this value in query, right? So the idea is that we need to understand real cases and also not super rare cases or non-existing at all cases, but we need to understand the cases which hurt user experience, for example, and focus on them. In this case, generic plan is something really weird in this picture I just painted, right? So what do you think? Like generic and custom, and maybe let's talk how Planner uses them, and then discuss what should we do about it at all. So this 5 times rule, what do you think?
Yeah, I think that catches people out sometimes. So the way prepared statements works, or at least my understanding, is that you can prepare a query in advance, and that will do like the parse stage, and it will do like several stages up to but not including the execution of that query. Then you can ask it to execute with parameters. Now that then on the subsequent executions, you don't have to reparse, do the set, like Postgres doesn't have to do several of those. Well, planning at first does have to be done again, right? So it's the parsing and like the rewriting stages. Yes, on a per session basis, we don't have to do several of those steps, but there is also this weird kind of initial phase. So if you've prepared the statement and then you execute it, the first 5 times, Postgres will plan each of those 5 executions separately based on the parameters that are given. So if those are, in the case you gave, if you used true, was it that was 90% of the time? If you use true every single time for those 5 times, it's going to plan it the same way each time. And on the 6th execution, it will then look at the cost of planning. And if that cost is less than a generic, or if it's more than a generic plan that it's calculated, or I think there's some subtlety around exactly how precise that is, then it will choose its generic plan thereafter. It will flip to not planning each new execution. So 6th time, 7th time, 8th time, 9th time, forever onwards, during that session, it won't replan. So now you're not only saving on the parsing, on the rewriting stages, you're also saving on the planning stage, which you mentioned already. But that's not true if, for example, you did 3 or 4 executions with true and then a couple of executions with false in your example. Then you're going to get a different kind of average cost for those 5 executions. Then that will get compared to the generic plan, and then a different decision will get made. So depending on those first 5, so those first 5 do actually determine quite a lot what happens thereafter, which is interesting. But yeah, the one time I've seen that the 5 become important is, this can be really confusing for folks if you're trying to debug something and it's fast for a while and then suddenly it goes slow. This is one of those telltale signs once you've been around a while. If you notice that it's fast for 5 executions, then slow on the 6th, you should look into this issue, custom plan versus generic plan. It's kind of a telltale sign, like a smoking gun, or like it's a telltale sign that this could be what you're hitting. But aside from that, I haven't really thought too much about it. I don't think it's configurable, that 5 number. I think it's hard coded.
Yeah, it's. By the way, why 5? Right? Why 5?
Good question.
Some decision, right? That's it. But like, what is generic plan? Like, generic plan is just we don't take into account parameters at all, right? It means that we don't take into account this distribution of values, or we take.
Yeah, good question. Did you look into how it's calculated in the first place?
No, but it's an interesting question, right? And
I could be wrong, but I would have guessed that it would be based on some statistics at the time of if that would be, if you were implementing this feature, you would think if you've got a data distribution there, maybe you'd factor that in, but it's difficult because if it's skewed, if it's like completely uniform, it's quite easy. Like if we're talking about primary key lookups, it's a primary key lookup query and every single one's unique and every single one's only going to return 1 row. It's only scanning 1 table, that kind of thing. The generic plan is really easy because every single parameter you could provide to that is going to Like it is going to be planned the same way, even in the custom plan mode. So generic plan in that case is quite easy. But in the case where it's a skewed distribution, some values have more entries than others. It becomes tricky, I think, to know how you would plan that in a generic way. So I don't actually know.
For me, generic plan is a good thing that we don't have a lot of time to spend finding particular examples in logs or in persist activity. In persist activity, we have different problem. The how's called track activity size. So this parameter, which says by default is 1024, means that really long queries are truncated and we don't see the full query. And parameters usually are in the end, right? Like where select all columns, our favorite, right? From table and like so many column names, so I don't see parameter. Something equals truncated. I saw it not once. So when we don't want to spend time, we want like something really fast. This trick, prepare statement, we prepare statement, and then we use just nulls as all values. This gives us generic plan, but also we can say set plan cache mode to force generic plan, which exists in, as we just checked before we started recording this episode. We surprisingly plan cache mode configuration setting, it exists since many years ago. So it, in all current versions it's supported, right?
Yeah, since version 12. Yeah.
Exactly. So 12 is the oldest currently supported version.
Yeah.
Few months left till the end of it.
And
yeah. So we just, this trick like allows us to, looking at PG statements, and just take some normalized query which has this $1, $2, doesn't have parameters at all. They are removed, and just to use this prepared statements with nulls trick and get some generic plan and think already how bad situation in general, not in particular cases, but like overall. Like, but it doesn't work. This trick, as you absolutely correctly mentioned before this episode recording, it doesn't work if we have, for example, primary key there, because primary key equals null or is null. Won't work properly because there is not null constraint. So the planner knows that nothing will be returned. That doesn't show us the proper plan at all.
Yeah, if you don't specify like if you don't set plan cache mode to force generic plan, then you'll get a custom plan and the planner will shortcut it because there's a really but if you do force generic plan on version 12 onwards, then you will get the generic plan you're hoping for.
Well, that's great. I didn't realize that. So yeah, good. But if we are lucky enough to have already Postgres 16, all these tricks are not needed because we can just say explain generic plan. There is a new option in explain command, and this is very handy, right? We just ask a generic plan and explain. Don't care about. And interesting that we can even use $1, $2 and this query text right from PG statements. This is super convenient. We can say explain generic plan and that text. We can even probably automate this, right? And
good point.
See, for example, if we have sequential scans in generic plans and like put warnings somewhere and so on. But of course, this won't work if we want to execute and we want to explain analyze buffers. This won't work. I mean, in this case, we need to replace $1, $2 with some values.
Yeah, and it makes sense, right? Like we can't do the execution unless we specify some value. Right. Like otherwise, what are you executing? Right. So it makes sense. And kudos to Lawrence from Cybertech who added this and has blogged about it. So I'll share the blog post about that.
I remember actually this wave from Lawrence and also Lucas Fittel, PGAnalyze, blogging about generic plans and also getting excited. Also Frank Pachot, I think, joined at some point. I actually don't know who started this, but I remember wave of thinking. Multiple blog authors blog posted about this generic plans a few years ago, and it was great.
I don't think it's super surprising that this has come out of a consultancy, like a Postgres consultancy, and that Lucas is excited about it as well. I think it's one of those things that really helps people help others. Because if you really know what you're doing, like these people all do, you can now set up Postgres in a way where you can find parameter values in the vast majority of cases, or you can reconfigure things so that it does log the query ID, or you can get your slowest queries logged with parameters. So there are these ways of doing it now. But if people haven't set that up in advance and you're helping them with a production issue, this is a really helpful tool to give you a clue as to what's going on. Now, explain will always, there will only ever be a clue, not because you don't have the execution statistics, you don't know for sure why it's slow. But those clues are often enough for experienced people to get a theory, get a hypothesis as to what's going wrong, and then gives them something to be getting on with, instead of being able to say, I have no idea why this is, like, instead of, it's kind of like extra information to make the guest a little bit more educated rather than an actual answer.
Yeah, and we can have holistic approach now, like checking everything in an automated fashion, not guessing and so on. It's great. So yeah, what else worth mentioning in this area? Maybe partitioning, which we like. It's funny that you found this commit in Postgres 15, right? Which improved situation. My general impression, if you use a lot of partitioning, you should perform major upgrades promptly, not lagging at all, because every year a lot of things are improved. So this is a quite in-depth thing that was improved in Postgres 15, saying that now, like partition pruning, so exclusion for irrelevant partitions based on like if user asks to return some data in query, Postgres can remove partitions which are for sure irrelevant from consideration. For example, we have partitioning by time, range by time and by date, and then user for sure wants fresh data. We definitely didn't need to look at very old partitions with very old data. But this might happen both at planning time and execution time, which can be a big surprise. And you want this to happen at planning time, basically, better, because this will mean that we can rely later on cached plan, or if we use prepared statements, we can rely more on cached plans, and then we have very good situation when partition pruning was already done at planning time. We just execute, that's it. But it's tricky when we talk about generic plan, because generic plan doesn't take into account the values. So something was improved in Postgres 15 in this area, right?
Or we tried to look into it before the call, didn't we? And couldn't.
Yeah, I couldn't reproduce the problem somehow.
Yeah, so we tried on an old version before 13. These. Yeah. So it would be interesting to hear from people that have reproduced this, or I didn't see a blog post about it. I saw it referenced a couple of times.
Yeah, Lucas Fittel in this blog post, generalized blog post, mentioned that before we had a problem with generic plans, that partition pruning didn't work at planning time. It worked only at execution time. I couldn't reproduce it, but if it's so, it means that, for example, if you have a lot of partitions with a lot of indexes, and at execution time you involve all of them. Like in general, if you have a lot of partitions, it's just checking them, not returning everything. It's big overhead, huge overhead, right? But at least at execution time, Postgres doesn't put locks, access share locks on all indexes, because at planning time it does. And if at planning time we don't have partition pruning working, it's nightmare. This case of
even the
spikes, right?
Well, I think that would happen. Yeah. So a question for you, because we do now have this plan cache mode. So plan cache mode got added in 12. That's one of the things we can use to force generic plan, force custom plan while we're debugging, while we're trying to like pre-version 16 releases, before we had this explain generic plan, we could use that for debugging. But I don't think I've ever seen anybody change. So plan cache mode got added. you have three options: auto, force custom plan, and force generic plan.
Right.
Auto is the default. So auto acts as it did as
you described.
Yes. So the first five executions.
Times custom, then decision is made.
Yeah.
What to choose.
Well, I was going to ask, because I think I got the impression that some of these ORMs, like Active Record, for example, uses prepared statements. I got the impression the main reason they do so is to protect against SQL injection attacks, not for performance reasons. That might be not quite accurate, but there is this other benefit that seems to be mentioned quite a lot around prepared statements. Now, I wondered if you'd ever seen anybody change, like if you only were using prepared statements for SQL injection protection, and you weren't as bothered about the performance benefits in some cases or pitfalls in other cases, you might want to allow Postgres to replan every single time. And I could imagine some people considering turning force custom plan on. I can imagine like the upside of doing so. I can't see quite the same upside for doing force generic plan, because all you're doing is saving those five. Well, I think you'd only save those 5 executions and then you flip to the generic plan anyway. Maybe there's another case for that. But yeah, have you seen anybody changing that setting in any cases?
I see everyone doesn't know about it almost ever. It's very deep. It's not super. It's it feels like some kind of fine tuning. I see people have fears, for example, to rely on prepared statements globally, because with the idea, what if global plan will work not well, right? And
so if generic plan is bad for a specific parameter,
if generic plan is chosen, cached, and then it's bad for some cases, and we have performance degradation for particular parameters. But also, I think this idea to use prepared statements, I don't think these days it already matters as protection from. I think the main reason is planning time is usually fast, but not always fast, as we know. And the idea that during planning time Postgres logs all indexes, it's super big surprise. Many people, including myself, had not long ago, right? And we had benchmarks showing this small overhead adding with each index for select, not for update, for select, right? And at some point, when total number of relations, both tables and indexes, reaches 16, which is also hard-coded constant, if query is very frequent, 1,000 or 2,000 per second, primary key lookups usually are so. We have log manager spike, and partitioning increases the probability of it, and that's why getting rid of planning is good. And when you get rid of planning, it's worth understanding this behavior of how caching works and generic versus custom. But in just changing this globally, I'm not sure like this is popular decision. But of course, my experience is very limited. So
well, let us know if you have changed it. It'd be interesting to hear from you.
Yeah, it's an interesting topic anyway. But in general, I think it's worth spending efforts to get rid of planning for high frequent queries, especially for partition tables.
I have one more related question. So now PG Bouncer supports prepared statements. I saw they have a max prepared state. Well, so it's off by default, which I didn't realize. They have a max prepared statements parameter. Do you have any opinions on tuning that? Or like I saw that they said a default of 100 might make sense. Like might be a
some high value is good. I think it's like depends on situation, of course, right? I mean, but in general, it's not an issue to just increase it. Yeah,
cool.
But again, I see the tendency to be afraid of turning prepared statements globally in already existing heavily loaded projects. If you start from scratch, it's a very good decision to make, to start using prepared statements from very beginning. And then you just grow and see the problems, fix them as usual, like you would do anyway. And then this confidence level of using already there, but switching for a big project from 0 to 100% coverage prepare statements. Oh, it's very hard decision to make.
Hard as in scary, or
just people are not sure, and that's the problem. And there is no good path. Maybe there is good path to it, but in a couple of big companies I observed recently, people decided not to proceed with this after a lot of consideration. Yeah, and it's kind of interesting topic. Instead, it feels safer to start using prepared statements only for specific queries.
It's a slow way in.
Yeah,
maybe for new features.
Not new features. No, not at all. Again, the problem is usually this log manager overhead when we have
sure
1,000, 2,000 QPS. We see very simple queries: select star from or select something from table where ID equals something, primary key lookup. And if we have planning time every time, select itself is fast. Planning itself is also fast. But if you have a lot of backends competing, access share log, it's not a problem at all, right? But log manager has overhead because of fast path is false. And this is what multiple companies experienced recently. And Jeremy Schneider said log manager strikes back or bites back or something like that, right? Last year was log manager year of in terms of performance issues people experienced.
So you're saying, yeah, so I'll share the episode where we discussed that in more detail. And so you're saying they choose to turn prepared statements on only for those queries, right, because it reduces the issue there, but not globally. Yeah. Right. Okay, makes sense.
Just to remove these hotspots.
Yeah.
Right. Only for these primary key lookups.
I mean, so if you're talking about these super fast queries, even though both execution and planning time are fast, it could be that planning time is more than execution time. It's quite common.
It happens.
So even if it wasn't for the issues you're describing, you could maybe increase throughput, or there's a lot of overhead to be gained by not having to plan those queries.
Yeah, shave off planning time is a good idea in many cases, and in general. It's for example, partitioning, right? If partitioning is there, if planning time can be high, and if you have a lot, it can depend on number of partitions. This is the problem as well. And in this case, of course, getting rid of it's good.
Nice. Cool. Anything else you wanted to add for this one?
No. So it's an interesting thing to keep in mind when dealing with plan optimization. So use explain generic plan in Postgres 16 and in future Postgres versions.
Yeah, if you can't as a starting point, or if you can't
lazy mode
parameters.
If you don't want to go to logs to find examples, or maybe log manipulation statement was not configured somehow. This is
exactly. If it wasn't configured for the time where you're having issues,
right?
Or if you can't turn it on easily, like if you have got a lot of process at your company before changing some of these parameters, there might be reasons why you can't get real values. But of course, I think the reason I don't know as much as maybe I should on this is if you can get the real values, performance optimization work becomes so much easier.
Of course,
there's less guesswork. Yeah.
This generic plan should be something like partial solution to in terms of analysis. It's a partial analysis. It's always should be with remark, this is not maybe not it. Maybe, but maybe not.
Yeah. Like a stepping stone on the way to the solution, but it's not it's not a solution in itself.
Right. On the other hand, it might give very quick insights what to do and how to speed up. So
yeah, good point. Yeah, good point.
Good. Yeah.
Nice one, Nikolay. Thank you so much.
Thank you. Have a good day. Bye.
You too. Bye.